Okay, so today's video is going to cover the chain rule. This is standard D3. Please put that in your table of contents. The target is students will find the derivative of a composite function by using the chain rule to find the instantaneous rate of change. So let's think about this function here. You don't have this on your paper, so I really just want you paying attention and watching. So I have two options. I can either expand it. Sorry, let me get a pen. So if I expand it to 2x plus 1 times 2x plus 1 times 2x plus 1. Okay, I could do that. That's one of my options. I could FOIL out one of these or distribute out one of these to get 4x squared plus 4x plus 1. Okay, 2x plus 1. Then I could use the product rule there. I can continue expanding, then do my derivative. It doesn't matter, but there is going to have to be some major work done. So let's see if we get the derivative using the product rule, because that's something that we're having a quiz on tomorrow. Okay, so if I take the derivative of the first, I'm going to get 8x plus 4 times the second plus derivative of the second, so just 2 times the first sorry, that should be a 1, not a 2. Okay, so I have that. I would have to expand it again. I would get 16x squared plus 8x plus 8x plus 4. I'd get another 8x squared here, another 8x, and plus 2. Then if I combine my like terms, I'd get 24x squared. That covers that and that. I'd also have 24x. That covers that and that. And of course, I would get plus 6. Okay. So if I asked you to factor this, hopefully most of you could do that. I'd get something like a GCF of 6. Then that would give me 4x squared plus 4x plus 1. And I can factor it again. If we think about going back here, what we did and how we got that, those are the same thing. So I'd get 6 times 2x plus 1 squared. Okay, very similar to the original problem, with the exception of this 3, or this 6. Okay, just like with our power rule, this is expanded by 1, okay, or it's decreased by 1. So the question is, where's the 6 coming from? Okay, we've done the process, we've done a process that we know, so we know it's a valid answer, but that's 6. It's kind of weird to see where that 6 is coming from. But that leads us to our next rule. It's called the chain rule, as you can see from the top. And if we think about it, if we think about the original function, that's considered to be a composite function. Now the chain rule is for functions that we consider to be composite functions. So let's do a quick review of what it means to be a composite function. So in pre-cal we learned composites, things like f of x. If we compose f of x and g of x, we can get it to be f of g of x. And that just means we're taking g of x, shoving it into f of x for every x. Okay, so if we have a function like h of x, which is right there, if we think about decomposing, our g of x is what's on the inside, our f is what's on the outside. So we consider our f of x and our g of x. Sorry, give me more room since I write so big. G of x. I always start with the inside piece. So the inside piece is my g of x, and that's that x cubed plus x squared. So if we take that out, this piece right here, for our outside function, that's our x, now raised to the 5th. So if we compose those, we get that h of x is equal to that x cubed plus x squared to the 5th power. Remember, we're taking our g of x and not doing that. we're taking that g of x and plugging it into f of x. So in pre-cal we spent most of our time composing, but decomposing and taking them apart kind of helps us here. And that's because we need to understand the difference between our inside function versus our outside function. Now our outside function is to the 5th power because it's on the outside of the parentheses. My inside function is x cubed plus x squared. Okay, so our new rule is what we call the chain rule. And the chain rule says if I take the derivative of a composite function up there, that really I'm going to get the derivative of the outside function, f prime, with the inside the same, g of x, times the derivative of the inside. Okay, so again, I'm going to highlight the words and we're going to repeat these in class tomorrow. Okay, so the way we describe the chain rule is we're taking the derivative of the outside with the inside the same times the derivative of the inside. So now going back to our actual equation, so this one right here, which was part of what I did on the first screen, exact same function. If we think about the outside, now the outside is a cube, okay? That's a power rule. So we could take the derivative, f prime of x, and I'm really just worried about the outside piece. So if I take the derivative of the outside, I'm going to bring that 3 in front as part of the power rule. Squared goes down by 1. Now the chain rule says we need to leave the inside the same and then come back and multiply it by the derivative of the inside piece, which happens to be 2. And if we simplify this, anytime you can simplify these, it's going to be that front piece to that back piece. That's what you're going to be able to be multiplied. Leave the parentheses alone. So 3 times 2 gives us 6. And that's exactly what we had on that front page. Going back to what we did earlier, that is exactly what we got. And we did it the long way, but the chain rule gives us a shortcut to even that process. Okay, so really it's just the derivative of the outside with the inside the same times the derivative of the inside. Every other property that we've learned to this point still applies. So let's look at the next one. If we have f of x is equal to the square root, well, the minute I see a square root, like if it was just the square root of x, the first thing I'm going to do is rewrite it. Because when I do, that puts it into the form like the first problem, where my outside is a power of 1/2, that inside is that quadratic. So now applying the rule says take the derivative. We take the derivative of the outside, so that 1/2 is going to come in front. Derivative of the outside with the inside the same, so 2x squared minus 4x. And then we're going to come back and multiply by the derivative of the inside. And here our parentheses are going to be pretty necessary. Okay, so derivative of the inside gives us 4x minus 4. Okay. Again, if I'm going to simplify front to back, that's where I'm going to want to simplify. So if I distribute that 1/2 in there, I have 2x squared minus 4x raised to the negative 1/2. And then 1/2 in will give us 2x minus 2. Okay. Now I'm going just like I did with power rule from the beginning. I'm going to put it back into its original form. Negative exponents, we need to make that positive. So I'm creating my fraction. Negative exponent is going to go on the bottom because it's going to go down to make it positive, the exponent positive, and back into root form. We know that the 1/2 power is a square root. So let's just go straight there. And I get that. That 2x minus 2 has a positive power of 1. So that's going to stay in my numerator. So 2x minus 2. And you don't need the parentheses. You can just leave it like that. So there is our derivative. Let's look at another one. Okay, so the next one, we could look at it as a quotient, but because all of the x's pretty much lie in our denominator and it's raised to an exponent, I'm going to treat it just like we would like a square root that's in my denominator. I know one of the rules says that 4 is going to stay a 4, so let's leave it. And I can pull up the bottom by negating the exponent. Okay. And now it's just like a problem like the ones on the front. So I'm going to treat it the same. So now my g prime, chain rule says derivative of the outside, so our -2 exponent and that 4 are going to become -8, -2 times 4. Subtract 1, so -3, with the inside the same, times the derivative of the inside, which happens to be 3x squared. Okay. Again, front to back, -8 times 3x squared gives us -24x squared times x cubed minus 3 to the -3 power. Negative exponents means I need to change this location. The first term has positive, so it's going to stay in my numerator. And the other part has a negative exponent, so it's going to come to my denominator to make it positive. And there's our derivative. Okay. Now, with sine squared x, we know another way to write sine squared x is to use parentheses. Okay, we talked about this for the last 2 days. That's another way to write. So in this case, to take the derivative of something like this, it's beneficial to write it the other way. Because now we see the layers. What we're doing is we're taking derivative layer by layer. So h prime, derivative of the outside, goes to the first power, with the inside the same, times the derivative of the inside, which happens to be cosine. Okay. So 2 cosine x, sine x is now to the first power, so we can leave it like that. That happens to be one of our identities. So this is actually the double angle identity for sine. Remember, we only change what comes behind the sign with a trig identity. If not, what comes behind the sign stays behind the sign. Okay. So h of x, kind of the same thing. It already has parentheses in it. So my outside piece is the cosine. So h prime, derivative of cosine gives us negative sine, with the inside the same, times the derivative of the inside, which happens to be 6. Front to back, remember that negative is not attached to sine, that negative is attached to the 1 in front of sine. So -1 times a positive 6 gives us a -6 sine 6x. Even in this process, what comes behind the trig stayed behind the trig. That didn't change. Okay, that next example I want to do in class because it's a little bit more complicated because it has more layers than the ones that we've done. Please remind me that we need to cover that one in class though. And let's see what our last examples are. Okay, so it says if f of x equals the square root of 25 minus x squared, find the equation of the line tangent when x is equal to 3. So this goes back to our 4-step process of finding the equation of the tangent line. First step is figuring out my y value. So we're going to take the x value and plug it in. Sorry, we're actually going to plug in the value, not the x. 3 squared gives us 9. 25 minus 9 is 16. And the square root of 16 is 4. So the point we're dealing with is 3, 4. Second step is to find the derivative. So the first thing I'm going to do is take my function, I'm not taking the derivative yet, and actually rewrite. Okay, now my derivative, so f prime, chain rule says 1/2 in front, derivative of the outside, with the inside the same, times the derivative of the inside, which happens to be -2x. Okay, I want to rewrite this. So 1/2 times that -2x is going to give us -x. And I'm going to just jump in because I already know that the -1/2, that -1/2 right there, is going to force it to go to the bottom and back into the square root form to the first power. So that's my step 2. Step 3, let's see if I can move this down. Making noises over here. Okay, so right there, just move it down a little bit. If you need more room, use a post-it note. Okay. So my step 3 is the plug-in to figure out the slope. So I'm going to take the value that I know, the 3, and plug it in. So -3 over the square root of 25 minus 3 squared. So I get -3. We've already calculated the bottom to be 4. So there's my slope. And then of course to answer the question, that's my step 4. So we use y equals my slope, my m, times x minus my x value plus my y value. And there's the equation of the tangent line. Now the next example says the equation of the normal line when x is equal to 3. The normal line and the tangent line both go through that same point of tangency, that 3, 4. A normal line, I've said this before, is a line perpendicular to the tangent. So if the slope of my tangent line is equal to -3/4, to find a perpendicular line, we do 2 things. This becomes the slope of the normal line, NORM for short. We, 1, change the sign, so it's going to be +3/4, and we do the reciprocal. So opposite reciprocal, if we remember that from Algebra 1, Geometry, and Algebra 2. Okay, so now I have the slope, I have a point, the point didn't change, which means all I have to do is actually plug into my step 4, because I already did all the work for this. So equals slope 4/3 times x minus 3 plus 4. If we were to graph those would be our perpendicular lines. Okay, remind me to go over that previous example, that one right there, make sure